Hello and welcome to fifth lecture in the 19th chapter of our comprehensive course on AI, ML and DS. Now in this lecture, we want to talk about statistical distributions, and this is one of the key fundamental understanding which is required even in the age of AI or whatever. Some basic intuition as soon as you see the data that you cannot expect from any artificial intelligence tool. Okay, so this statistical distribution is important thing. Now, what does statistical distribution mean? It is a general term which includes two things: data distribution and probability distribution. Now, one must understand the difference between the two, because many times a person has spent years in data science, 2 3 years, and still does not know clearly whether he is talking about data distribution or whether he is talking about probability distribution. In general, you can understand that when you are talking about existing given data, which is already given to you, then you are talking about data distribution. But mostly when you are talking about some prediction or some forecast, so at that time, that is, you are talking about some value for the response variable, then you can only talk with certain probability. So that means, suppose the very famous example which we have been doing is that you are asked that the age of the employee is this much. You have been given data set of maybe 1,000 employees of a company, and you are asked that age of these employees is in one column, seniority is in one column, their date of birth is in some other column, then maybe their educational qualification is in some new column, and their salary is what you want to predict based on three factors. Say, what is their educational qualification, what is their age, and what is their seniority. And of course, suppose gender is also fourth column. So you want to make sure that your organization is fair and follows the pay parity principles. That is, it does not discriminate between male and female in terms of pay. So in that case, suppose you are predicting the salary, you have built a model which predicts the salary using four factors: age, seniority in years, how many years the person has been working in your organization, gender, and educational qualification, right? And you find a predictive model. So say y salary is equal to beta 0 plus beta 1 into x1, where x1 is the age, plus beta 2 into x2, where x2 is the number of years the person has spent in your organization, seniority, plus beta 3 into x3, where x3 is the educational qualification which is encoded into numbers, plus beta 4 into age, okay, or some other fourth parameter, and you have made a model. Now using that model, when a new employee comes to you, for you are hiring say 10 new employees, so you know their age, their seniority is obviously 0. You are hiring, of course, if they have come from other organization where they have worked for maybe 10 years, then that seniority also you have to consider. So age, seniority, then maybe gender and qualification, all those things you are knowing, and you want to predict the salary so that you can offer the candidate the right salary. At the same time, you do not offer excessive salary so that your organization in which you are working as an HR head that suffers, right? So that predicted salary, that falls in the probability distribution, while the 1,000 employees data which you plot on a data set, that falls in the data distribution. That is one way of understanding that thing. Let us understand in still more depth. Data distribution refers to the way the data is spread or arranged, showing all possible values or intervals of data and how often they occur. So that is why the best way to look at data distribution is histogram, because histogram divides the data into bins. So age, for example, would be divided into maybe 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, like that. And you will see count in each age group. So there are intervals, 20 to 30, 30 to 40, and how many data points belong to each interval that you want to know. Okay, so histogram can be handy. You can also use the scatter plot. Okay, so histogram, bar chart, or scatter plot, these provide the snapshot of characteristic of a sample. Okay, what are the key points about data distribution? So data distribution usually have an empirical nature, because that represents the actual data which is collected in a study or observed in an experiment. How you have collected the data of 1,000 employees, then obviously you have collected using some kind of survey. So that is called an experiment in HR, that you have collected the data using some kind of survey. Similarly, there is another experiment which is often done in HR department, that is how employees sentiment is currently. Is their moral down, maybe due to invasion of IT AI tools? Maybe your tech department employees are having slightly down moral, and many of them have started to look for alternative careers. Now that would obviously reflect on the performance of your firm. So at that time also, employee surveys are carried out, and they are encouraged to speak their mind, and ensuring that their responses will remain anonymous, and it will not go against their salary or any of their performance ranking or anything. They are encouraged to freely express if they have any problem with the working style of the organization, if they have any complaint against the manager, if they have in general some other complaint, like as I said, AI tools are invading and they are facing some kind of insecurity that my job is going to suffer or something. So that is another experiment, and then you collect the data, employee's age, and then employee's current position, employee's current salary, and then how he is feeling on maybe confidence, how he is feeling, what is his ranking of his immediate boss, that is his immediate manager, what is his ranking of overall whole organization as a whole for employee friendliness, like that. And then you decide on the basis of that maybe if you calculate the probability, how many percentage of employee are likely to churn. Likely to churn means they are likely to leave your firm and maybe join your competitor, or maybe join some further study. Suddenly they feel that they have to get a degree in AI or something. So that thing you can predict. Now if 20% of your key employees leave, then obviously your organization would be in trouble. So that kind of experiments are done in organization, but it is an empirical study. So that is what empirical means, something which is done in practice. It is not a mathematical calculation. Okay, but once that study is made, data is collected, its plotting etc. is also done. That is data distribution. But then you predict that okay, 10% of the employee are likely to churn, 15% employee are likely to churn, and which employees are likely to churn. Then you plot them on a graph. That is called probability distribution, because no machine learning predictive model can predict with 100% probability. So it is always around 95% probability is considered good enough for most of that. That is 95% confidence interval, and plus or minus 5% error in the various metrics is always considered good enough for most of the application, except life-threatening application like medical healthcare applications. Okay, then. So first point about data distribution is that they are empirical. Second point is that they are typically visualized through histogram or scatter plot, where frequency of each value or range of value is plotted. And description, they can be described by which parameters? Then we know df.describe. And when you write, you find mean, median, then mode, then variance, skewness, kurtosis, etc. That gives about three things. One, what measures of central tendency. Two, measures of dispersion, variability. And three, measures of distortion in the shape. That is given by skew and kurtosis, right? So this I have just plotted just now, just pasted just now, that histogram is considered good for describing data distribution. But scatter plot is also considered good. Suppose you have this kind of scatter plot of some experiment, and a very simple experiment we are taking, not many features, just y varies on x with x, one independent variable x and one dependent variable y. Okay, so, and in that case, suppose you get this kind of data of xy scatter plot is this, then you can immediately say that roughly linear behavior can be seen with some deviation on either side of linear that straight line, correct? So this is how data distribution is normally represented. Now then, what is probability distribution? Data distribution is empirical, but probability distribution is just a mathematical function which provides the probability of occurrence of different possible outcome in the experiment. That's why I said that the response variable, when you plot the response on a graph paper or something, then that is called probability distribution of how many employees are likely to churn, or probability distribution of what will be the salary distribution of 10 new persons which I am hiring in my department. Okay, so it is mainly a theoretical model. So it is possible that when you actually arrange the interview, then if job market at that time is dull, then you may get the same qualification and same experience or even better employee at a lower salary than what your model has predicted. On the other hand, if job market is hot and a particular skill is in big demand, then it is also possible that your theoretical model predicted that the total salary bill of the 10 new employees which you are hiring is maybe $20,000 per month or $2 lakh per month, but instead your organization has to fork out to $2,20,000 per month. So that is 10% higher amount you have to fork out, because the skill which you are hiring is in high demand. So it is just a theoretical model which describes how outcome of random variables are distributed. Okay, so what is the key point about the probability distribution? It is a theoretical model. Unlike data distribution, which is empirical model, probability distributions are theoretical model, and they provide a model of how data points are expected to behave, while this data distribution that describe how the data points are actually behaving. So there is my existing data, while here I am talking about, when I talk about probability distribution, I am talking about some predicted data of a predicted response variable. So I can only say that the response variable that is expected to behave according to this distribution. Now in probability distribution, there are many ways of classifying them, but the most easiest way of classifying them is discrete probability distribution versus continuous probability distribution. In very common language, I can say that discrete probability distribution is that for which the graph, if you try to plot, you cannot plot the graph covering entire data distribution without lifting your pen from the graph paper. For example, binomial Poisson, etc. So here some discrete are shown, the lower three, binomial, geometric, and hypergeometric. So that means if I plotted the graph, here this is the point, here this is the point, here this vertical line, this vertical line. But you can see that after plotting each vertical line, I have to lift my pen to go to next point. There is nothing in between these two. That is the meaning of the discrete. Okay. So first possible value is say 2, then the next possible value is say 5, next possible value is say 7. But there cannot be any value between 5 and 7 like 5.25, 5.23, 5.24 like that. So there is no smooth curve joining them. So this type of data distribution in which you have to lift your pen to complete the data distribution, that is called discrete data distribution. On the other hand, if you can draw the entire data distribution continuously in one stroke of pen without needing to lift your pen from the paper, that type of distribution is called continuous data distribution. So here any value is possible for this y, for any value for x also. So if x is equal to 2, then next x can be 2.1, and even between 2 and 2.1, someone says 2.05 is possible. Yes, it is possible. Even between 2 and 2.05, someone says that 2.025 is possible. Then yes, it is possible. So that means that these are the various different values of y for these values of x. Okay. Now any and those values are continuous. There is no gap between them. That is the difference between this continuous distribution versus discrete distribution. Okay. Now I just want to still emphasize the nature of what is the meaning that data distribution is empirical or experimental, while probability distribution is theoretical. Okay. So let us see one thing. For example, look at this. The black is y-axis, this black is x-axis, and this red colored data point. Don't look at other things at present. But these red colored data points are the current distribution of salary. And suppose it is a simple model that salary depends upon the seniority. That is a very simple model. How many number of years? So the number of years in the organization, they are put in on x-axis, and the salary is put on y-axis. And I get this kind of data distribution for my sample. So my organization gave me the whole population, whole data set of maybe large number of employees, but from which I found one suitably representative sample, and I got this is the data distribution. And using that data distribution, I did my standard things. What is that standard thing? If you remember, we divide our data into two parts. So what two parts? First part is this, which is called train set. This part, train set. 80% of the data is around kept in the train set. Okay, because we want to get a predictive model which can predict the salary y based on x, the number of years which the person has spent in the organization, which I will now onwards call x is equal to seniority. So I want to find some equation like this. Okay, this kind of equation, that y is equal to 5x plus 3 plus or minus 5% or 0.05. Okay, that equation is itself called a mathematical model for predicting salary based on the seniority x. Okay, now for doing that, for making this equation, that means indirectly we are finding this 5 and 3. Okay, that is beta 0 and beta 1, two unknowns. Once these two are found, then we can confidently put them in one equation, and then for any other value of seniority or any outside sample, we can easily calculate that salary for that much seniority. Or a new person is recruited. So here somewhere his seniority is say just 6 months. He has just worked as an intern maybe somewhere 6 months, for 6 months. So his seniority is just 6 months. But your sample did not have anyone with just that small seniority. So the question is how much salary you should offer. Then for 6 months, here you will put x is equal to 1 by 2, and this model is there. So 5 into 1 by 2 plus 3. So that is 2.5 plus 3, $5.5 thousand maybe per year or whatever. That is depending upon the country in which you are living. But that is how you can build the predictive model. Correct? Now the question is, do we get this kind of equation by using some mathematical calculation or calculator or some calculus or no? What we do is we have ready-made algorithms which we allow that algorithm to look through 80% of the data. That 80% of the data is called train set, and that means everything on the left side of this black vertical line, that is my train set. And we also look at the we do not allow the model to look at this remaining 20% of the data. That data is called test set. So between this black line and this orange vertical line, that is my test set. So my model passes through this 80% of the data. It tries to find some patterns using this 80% of the data. The pattern means what? If x is this much, then it finds that y is this much. If x is this much, then y is this much. If x is this, then y is this. From which it tries to derive some such equation relating y and x. Okay, that means it tries to give that beta 0 and beta 1. And then we test the model based on that unknown data set, because we did not allow our algorithm to look at this, because that is the real test of any machine learning model, that it should be able to predict value on the unknown data, right? So that's why we kept 20% unknown, and now we are using that 20% to validate our model, or that means to find the accuracy of our model on unknown data. and we found that this model is say around suppose 89% accurate with plus or minus 5%, or that is that. So that is considered reasonably good accuracy for practical data sets, very good accuracy in fact. So then we accept that model, right? Now the question is, when I use this model, the important thing is this is called data distribution, the red color. Now the question is, when I use this model for hiring, say suppose my company suddenly got a big order, and I want to hire almost same number of employees and with almost the same different values of seniority from outside job market. So that are these employees. So the question is, how much will be the salary Y for them? So for them, I use my this model and I predict that model. Now, how to use that use model and predict? So same linear equation is used. So what prediction actually means is, this is called probability distribution. This is called data distribution, right? So prediction actually means trying to superimpose this probability distribution on the data distribution, right? Along with, of course, that red colored line, which is I think not coming, but I have to superimpose that probability distribution and data distribution, and I have to then think that how accurate this superimposition process will be. So I can say that if this kind of superimposition will occur, it will never perfectly coincide with that green line, but 89% accuracy means more or less I can say that the new salaries which I am predicting, that is the blue color probability distribution, and that is being predicted with how much confidence? That is being predicted with 95% of the confidence, right? So then the new salaries which I am predicting are matching with old salaries, or they will give correct prediction with a chance or with accuracy of 89%. So this is how we use this probability distribution and the data distribution while making prediction. And it is not necessary that every time you get a linear graph. Okay, so here for example, I try to undo things, and instead of linear graph, when this graph is here like this linear, but when you actually hired new employee, then you got maybe this kind of salary distribution. So that means you got a graph like this. Now you are in trouble because this is not now 89% accurate. That is clear. Okay, if I take this or maybe color also, I should select red, because but it is this kind of graph, somewhat parabolic in nature. Okay, so if I take this graph and try to superimpose on my original model, then you can see that my original model and was linear, but this graph is matching that old graph only for very small region. Okay, so that means that blue graph and the red graph, red has actually disappeared slightly because I think there is some issue. Yeah, so blue and red, I am keeping it, I am not leaving my cursor. So you can see that they are matching only for very small region, but as I try to predict further and further away, that phenomena is itself called extrapolation. While if I try to predict here only within my red colored data, then that is called interpolation. So you can see that in interpolation, the nature of the graph does not affect much, because even the curved graph will give more or less same values. But as I try to do extrapolation, as I try to go further and further away, different seniority ranges are I'm taking, then I can see that the values predicted by that linear graph green and the values predicted by the red graph, they are much different. So this model, if the model is say 5x square plus 3, so that is this parabolic model. Okay, so then in that case, that model will not give so high accuracy. It is possible that that model may give 90% accuracy, sorry, 80% accuracy. Okay, so then it is not necessary that your probability model will perfectly fit your data, probability distribution will perfectly fit your data distribution. But if it fits very nicely, then you will say that you have built a good model. And if it fits poorly, then you will say that you have built a poor quality model. Okay, so now I think the difference between probability distribution and data distribution should be clear. Okay, we will discuss. Yeah, so here what I have described is this thing. What is the connection between probability distribution and data distribution? While a data distribution describes what has actually occurred in a data set, so that is this red portion, that is my existing employees' data and their seniorities. A probability distribution models what we might to explain happen in a theoretical scenario for a future sample or assumptions. So that is, if I take some future employees I want to hire with a different seniority than my existing employees, then what might happen? So if I have model 5x plus 3, then that model you can see that it is fitting well. But if I build a model 5x square plus 3, that is this curved model, then that model will not be fitting well. So this is both linear model for the blue dots and this parabolic model for the blue dots. Both are theoretical models. So they just say that this might happen or this might happen. But how accurate they are, they will never give answer with 100% accuracy. But how accurate they are, that will decide which of them is a better model. Okay. So probability distribution describe what might expect to happen in a theoretical scenario for the future samples or assumptions based on observed frequency. And in practice, statisticians often fit probability distribution to data distribution. That is what I said here, that we try to fit the blue probability distribution which our model has given with the red data distribution to make prediction and infer probabilities about a population from which the sample was drawn. So this process involves statistical methods such as parameter estimation and goodness of fit test. What is parameter estimation? As I here said, that y is equal to beta 0 into x plus beta 1. Sorry, beta 0 plus beta 1 into x. That is the standard format. And if you find the value of those two constants, beta 0 and beta 1, then that itself will be called the model. So this everything which is enclosed in this red circle, that is the model. 5x plus 3. So 3 is beta 0 and 5 is beta 1. So beta 0 plus beta 1 into x, right? So that estimation of two parameters, beta 0 and beta 1, and the goodness of it. This shows the goodness of it, that the goodness of it is 89% with a probably with maybe 95% confidence interval. Okay, so then this is the meaning of the word probability distribution and data distribution, and this is the understanding how these two are connected. Okay, we will see that continue in the next lecture. So thank you, and this was very important lecture, so please refer and revise this again.